Today we're going to be talking about Earth's layers, so make sure you have your Earth layers notes in front of you. We have two ways of dividing Earth's layers: the compositional layers, which includes the crust, the mantle, and the core. The crust being on the outside, the mantle the middle, and the core is the innermost. And then we have the physical layers. We have the lithosphere on the top, the asthenosphere, and then the mesosphere. And then finally we have the inner and the outer core. When the Earth is divided into three compositional layers, you have the crust that is in the outermost. It's the area we live on. You'll find the continents and the oceans there. We have the mantle in the middle. It is the largest and thickest. And finally, we have the core in the middle. The crust is our outermost layer. Its temperatures range from 0 degrees Celsius to 1,000 degrees Celsius. It's about 5 kilometers to 100 kilometers, and it's composed of mostly oxygen, silicon, and aluminum. Again, the crust is where we live. It's the outermost. We actually have two types of crust. We have oceanic crust, which you'll find under the oceans. It's very thin and very dense, because remember, water is really heavy, so it's pressing down. And then we have continental crust. It's thick, but it's less dense. You can see the continental crust is very thick and it's less dense. There's more room for all that matter to move around. The oceanic crust, on the other hand, is squished down by the ocean, making it much more dense. The mantle is our next layer. It's located right below the crust. It's 1,000 degrees to 3,700 degrees Celsius. It's about 2,900 kilometers thick. It contains most of the Earth's mass, and it's solid and molten rock. The top of it is going to be that molten rock, that oozing, always moving rock, and below it is going to be the solid rock. And finally, we get to the center of our Earth, the core. It's about 3,700 degrees Celsius to 7,000 degrees Celsius. It's about 3,500 kilometers combined, but we do separate the core into the inner and the outer core because they are very different. They're composed mostly of iron and some nickel, the outer core being a liquid iron and nickel, and the inner core being solid. Now let's move on to the physical layers. There are 5 physical layers. The top physical layer is called the lithosphere. You'll find it on the very top, on the outermost edge of the Earth, and it's where we live. It also contains a small part of the upper mantle. The asthenosphere comes next. It's where the lithosphere floats. It's directly under the lithosphere. Next, we have the mesosphere, and finally the outer and the inner core. The lithosphere is that crunchy layer on the top of the Earth where we live. We say crunchy because it's mostly dirt and rocks and all that stuff that kind of crunches when you walk on it. It's in the crust and the upper mantle. So there's just that little bit of upper mantle, and it's all of the crust, including the continental and the oceanic crust. It's about 15 to 300 kilometers. And it's where our tectonic plates are, and we'll learn more about tectonic plates in a little while. Next, we come to the asthenosphere. It is in the middle mantle, right below the lithosphere. So again, we talked a little bit in the last slide about how the lithosphere floats on the asthenosphere. It's soft and it can bend like plastic. It's kind of like pudding or slime or putty. The lithosphere floats on this layer, just kind of like if you put a cookie on top of Jell-O and you shook it. And then finally, it's about 250 kilometers thick. And you can see we have the continental crust and the oceanic crust, which makes up the lithosphere and part of that upper mantle. And then we have the plastic-like, always moving asthenosphere. Directly under our asthenosphere is our mesosphere. It's a strong lower part of the mantle. It's the largest part of the mantle. It's about 25-50 kilometers thick. Now we're approaching the center of our Earth. The outer core is first, and it's liquid iron with some nickel. It's always moving because it's liquid, and it's actually what creates our magnetic field around the Earth. It's about 2,300 kilometers. And finally, we reach the inner core. It is solid iron and a little bit of nickel. It's about 1,200 kilometers, and it's solid because of the increased pressure. As we go in, the Earth's temperature increases, the Earth's density increases, and the pressure increases. So that very center has got all the pressure of the whole Earth on it. So it's very, very tight and dense. So as we look at our picture, that upper layer is the lithosphere. It contains the crust and a little bit of the upper part of the mantle. Next, we have the asthenosphere. Remember, the lithosphere is floating on top of the asthenosphere. That's that slow-moving putty-like material that's always moving. Directly under that, we have our mesosphere. That's the largest part, and it's solid. And then we end with our outer core that's liquid iron and nickel, and our inner core. So a little bit more about density, pressure, and temperature. As we move toward the center of the Earth, we're starting at the crust, which is the least dense, and we're moving in. So as we move in, the density is going to increase. The crust is the least dense, and then the mesosphere is a little more dense, the outer core is a little more dense, and finally, the inner core is the most dense. And then we have pressure. Again, everything's squeezing down. So the least pressure is on us, on the crust, and the most pressure is on that inner core. And finally, temperature. We know temperature increases because once we get to the inner core, it's as hot as the sun. It is certainly not as hot as the sun on the lithosphere where we live. So one of the big questions is, how do we know there are layers of the Earth? Well, earthquakes emit different kinds of seismic waves, and they travel differently through different substances. So they'll travel through the lithosphere slower than they'll travel through the asthenosphere, because the asthenosphere has a different density. Scientists use those waves to determine the layers based on the speed and the movement of the seismic waves. The MOHO is that boundary where the crust meets the mantle. This is super important because this is where it was first discovered that there was separate layers. As the seismic waves went through the crust and they got into the mantle, they started traveling at a different rate of speed. So that was a big discovery, that the MOHO, which is named after the man who discovered it, is where the density of the layers changes. Thus, we know we have different layers. It was discovered in 1909. And it was discovered because at this point the density changes, so the seismic waves travel faster and they change directions. So why does the Earth have a magnetic field? Well, it all boils down to that outer core. It's a result of the iron in that outer core that's liquid, that's always moving around. Remember, iron has the magnetic property, so that is really controlling that magnetic ring around the Earth. So let's review. What are the three main layers of the Earth? If If you said crust, mantle, and core, you are correct. Which layer is the least dense? That would be the crust. Which core is solid? Iron and nickel. Remember, one is solid, one is liquid. It is the inner core. What is the name given to that crunchy layer of the crust and the uppermost part of the mantle? Remember, this is where we walk on all that dirt and rocks. That would be our lithosphere. And finally, the motion of this layer is the reason Earth has its magnetic field. Remember all that liquid iron and nickel that's always moving? That would be our outer core.